In this video, I'm going to explain one data science project which is related to sales domain. So this dataset is provided by Walmart. I think you heard about Walmart in many countries. It is one of the top tier company selling different products in different domains. This dataset belongs to Walmart and we are going to find some interesting insights from this dataset with the help of statistics and Python. This is our major mission right now. We should have to accomplish this mission successfully. Before diving into the concept deeply, this dataset contains number of features related to Walmart sales history, such as sales of a product, time series data, and other supporting factors such as temperature, fuel price, etc. It is an all-rounded dataset. It contains lot of sales determining features to process, and lot of meaningful insights are also hidden in this dataset. As a data science knowing person, you should have to think very technically related to sales perspective. Then only you can able to collect some important insights from this dataset. I'm rating this project as a intermediate level because I implemented some intermediate level algorithms and little complex pandas syntaxes to collect some insights. And if you are a beginner in pandas, then you can easily understand the concepts. In case if you are a beginner in Python, then it is complicated to understand some logics. And if you want to know some baseline algorithms and statistics explanations, I created a separate playlist for you. You can go and check my videos. It is definitely useful content to gain some machine learning baseline knowledge. Okay. Before starting this video, do like, share, comment and subscribe to support your creator. It helps me to produce more new content and experiments in data science. Let's get started. In the first section, we have 4 different data sets that are training data, testing data, store information data and feature information data. This dataset has around 4.2 lakhs of data records. It means we have a lot of data to process in this project. First of all, don't worry about the dataset size, because I'm here to solve this problem with you. So stick with me till the end of this video, otherwise you can't understand the things that are present in this project. Okay, so let's explore the dataset. So in the training dataset, we have 5 columns. Store column contains the information of store ID and department column contains the information of department ID that are present in the stores. But understand, not all store contains all the same department sections. Some stores will give you some particular products. You can't expect all the department in a single store. It may differ from one store to another. For example, if store 1 has 3 departments and they are providing snacks, tech gadgets and groceries, but it may differ in store 2. It may have 4 departments, they are selling different products compared to the first one. You must need to understand this type of relation between the data, then only you can understand the sales project much better. Okay. And the third column contains the date feature and fourth column has the weekly sales. This is going to be our target column. So we are going to predict this column with some machine learning algorithms. And final column is our holiday column. It contains the boolean values such as true or false. It means either a holiday or not holiday kind of data. And second dataset is our test data. We are not going to use this dataset because I will split this training data and make one separate testing dataset for my validation. I'm leaving this dataset for now, and let's move to the third dataset. Third dataset is our feature dataset. It contains some environmental features that might affect our weekly sales. Some environmental features such as temperature, fuel price, unemployment and CPI. These features might get chance to affect the sales. But here we don't know how much these features are correlated to each other. We will find out more information about this feature in data analysis section. And the last dataset provides the information about the store capacity and types. This dataset will be crucial factor on sales. For example, if any store contains large number of capacity, then it will contribute lot of sales amount, and we can find more insights by using this dataset. So that's all about the dataset introduction. Let's move to the data analysis section. Now you are seeing my pre-coded version. I already collected all the insights that I felt were important. I will explain the code in a step-by-step manner so you guys can understand the logic that I implemented here. In the first part of my data analysis, I'm going to merge my training data with my feature data and stores data. By doing this, we can get cumulative understanding of our dataset. I wrote this code here. This code will perform my merging operation once I executed this column. So let me run this column. You can see here our datasets are merged together. Now look at the merged dataset. Apart from the normal feature, we have some extra features like markdowns. So what is the meaning of markdowns here? Markdowns are typically promotional features that is highly imbalanced here. Why I'm saying imbalance means this markdown data contains almost 58% of null values. I already checked with those columns. So it contains 58% of null values. So if we treat these values by statistics, it could end up overfitting issues. So I declared one variable called trainDF2, and in this variable I am dropping all the markdown features that I am having currently. Let's check the missing values in the dataset. Now we have 0 missing values, and let's process this data further. In the next cell, I'm checking the outlier data. So you guys must understand one thing. If you're doing your analysis on sales data, always check for negative values. Negative records are meaningless data. So no one can expect negative sales values in Walmart kind of companies. So always check this thing in any sales data. Okay. Here I wrote the code for checking the negative values, and look at this. There are around 1358 data records or outliers. So we can remove this data from our data set. After removing the outliers, this is our data set looks like. So now we can take some productive insights from this data set. First, I'm going to take how many type of stores are present in the Walmart. For that, I printed down the unique values from the type column. We have around 3 different types of stores are available in Walmart. Now let's check how much each store contributed towards the sales. So in this cell, I wrote the logic for that. Let's run this cell to know which type of stores are contributed more towards the sales. See here, type A store contributed around 51% and remaining stores are contributed 49% overall. So this is our first insight. Before moving into the next insight, I'm going to extract the year, month, week data separately from the date column. Here I wrote the code for separating the month, year and week indexes from the date column. Each one of them gives some separate meaning towards the sales. Okay, so that's why I separate these 3 things from the date column. Next step, we are going to form the correlation matrix between the each features that we have. So look at this cell. I wrote the code for correlation matrix. Once I executed this cell, you will see the beautiful heat map which contains the correlation data interpretation. So let's run this cell. So see this beautiful heat map visualization. It explains which features in our dataset are highly dependent on each other. I'm noticing a few features that highly rely on each other. For example, take the fuel price versus year. The correlation is 0.78. It is highly positive correlation. And next one is the weekly sales versus size. It has one positive correlation of 0.24. Other than this, we have some positive correlation, and let's compare and visualize those positive correlations. Okay. The first one is the fuel price versus year. Here I wrote the code in matplotlib. Let's run this cell. You can see here in 2010 the fuel price is low, but in 2011 it rises up, and in 2012 it again rises up. So this is the explanation of correlation. Simply if one variable increases, other variable also increase. It is called positive correlation. And the negative correlation means opposite statement of the previous one. If one variable decreases and the other one also decrease. So it is called negative correlation. If you are a beginner in statistics, then correlation is one of the very important topic to know. This definition is good to know. After that, let's check weekly sales versus store. Here I wrote the code for comparing the weekly sales over different Walmart stores. So let's run this cell. See this graph, we have around 45 different stores available, and these are the overall weekly sales for each and every store respectively. And next one is store versus unemployment. There are few spikes over the entire graph. It means only few number of unemployment happened in entire 45 Walmart stores. So let's move to the next insight. In this insight, I compared weekly sales versus department. So look at this graph. In the 45 Walmart stores, we have around 99 different types of departments are there. I can see 6 good sales spikes. It means the Walmart sales are quite moderate over 2010, 2011 and 2012. In the next insight, I formed a pivot table. With this pivot table, I can able to find which month sales have peaked up. So in the year 2010, 2011 and 2012, Walmart have good sales over 3 months which happened in year ends. And if you look at the graph closely, you can see in the 10th month of those years, the sales have started to pick up. It is because of festival season. Lot of people show interest towards buying new items during the winter and Christmas seasons. So this is the reason behind the sales according to my logic. Actually, I forgot one transformation step. I have to change the 2 labeled column into numerical ones. If you look at the data set, in the holiday and type column contains some string denotations. It is not good for machine learning processing. I'm just using label encoder here to transform my label data into numericals. Now my data is transformed into numericals. And that's all about the data analysis section. Now let's start the feature selection part. For selecting the features of my dataset, I'm going to use random forest regression algorithm. So using the random forest regression, we can easily find out the feature importances. Actually, I found this trick while writing this code. I never knew this feature before. So I'm now going to check out each feature strength by random forest regression test. And before implementing the random forest regression, I dropped my target column weekly sales into a separate data frame. All the features are stored in the feature variable and my target column is stored in the target variable. And let's run the random forest regression. I'm running all the algorithms on a default parameters. I just want to analyze the algorithm performances without hyperparameter tuning. I will conduct the hyperparameter tuning later because it is a much bigger process than writing the entire code. That's why I test with default parameters. Now our random forest regression is finished. Let's check the important feature from the random forest results. Here I wrote some code to visualize the feature importance graph. There are a lot of feature importance techniques are there. You can try different statistical approaches. Why I'm selecting random forest means random forest generally check the information gain metric between the parameters. That's why I choose the random forest. By seeing this graph, you can get some insights about which features we can use for machine learning modeling, and let's drop some unimportant features from this dataset. Now our final dataset is ready. Let's split the dataset and apply on different algorithms. I'm going to apply this dataset on 4 different algorithms. First, I'm going to apply this on decision tree algorithm, and I got 0.3 auto score, which is pretty good, and RMSE score is also very high. It is not good. Let's try on random forest regression. And look at this, I got massive improvements compared to decision tree. And let's check with the boosting algorithm. The boosting results are pretty much clear compared to the standalone ML models. I got good auto score and the error rate is also low. It means XGBoost is working really fine on our dataset. Finally, I'm trying a regularization technique called ridge regression. Why I'm using the regularization technique means it prevents overfitting in our dataset. That's the main advantage of using regularization. In the regularization, I got same results as the previous one. There is no improvements. So you should understand one thing, this type of dataset requires hyperparameter tuning. Without hyperparameter tuning, we can't finalize the model results. So the influence of hyperparameter tuning is very much important here when you are working with this type of real-time datasets. I will update the hyperparameter tuning results in this notebook. I'm sure that this will improve the model accuracy way better than now. The problem is it takes a lot of time to process the entire dataset, and we should implement some trial and error approaches on parameters to extract best from the above models. So I will handle those things, don't worry. And that's all about this video. Thanks for watching and thank you. See you on next video.